Welcome to our tech classes. Greetings of the day. So in this lecture, I would like to explain about the SCR turn-off methods. Okay. Topic of the day is SCR turn-off methods. Okay. The turn-off methods is also known as commutation methods. Okay. The turn-off method is also known as commutation methods. Okay, now why we are going to study about this turn-off methods? Why? Because SCR is basically which type of device? It is a controlled turn on and uncontrolled turn off device. Uncontrolled turn off device. Okay, so it is SCR is a control turn on and uncontrolled turn off device. So due to this reason, we are studying about this topic. Okay, so here the two terms are there. One is controlled turn on and another one is uncontrolled turn off. Okay, so controlled means to turn off this SCR, to turn off. So here I am taking the one symbol and also observe this one. Okay, so controlled turn on means whenever the current is flows from anode to cathode, then SCR is said to be in on state. That means whenever anode current, so whenever anode current is reaches to the cathode current. Okay, so whenever the current is flows from anode current to cathode current, then SCR is said to be in on state. So this can be achieved by with the help of gate terminal. Okay, so during the forward bias condition, the two junctions, outer layer junctions are forward biased and middle junction is reverse biased. So the reverse biased junction is forward biased by the using of this gate terminal. So with the help of this gate terminal, we can turn on this SCR. So with the help of the gate terminal. So that's why it can be a control turn on device. That means to turn on this SCR by using of this gate terminal. That means gate is the control of to turn on this SCR. But wait, so after this turn on of the device, so it cannot be turned off. So even though if you remove the gate terminal in the SCR, it cannot be turned off. That means there is no control over this device whenever turn off in the case. Okay, so due to that reason, we need to study about this turn off methods. Okay, now coming to what are the methods are there to turn off this SCR. So basically we have the two types of methods are there. One is the natural commutation and another one is forced commutation. Okay, natural commutation is applicable in AC supply circuits, whereas forced commutation is applied in case of DC supply circuits. Okay, and basically we know that commutation means we have to apply the reverse voltage to the circuit, to the SCR, then forward current or anode current is opposite to this commutation current, then the resultant current is decreased. Okay, and one more point is here, So when we can say the SCR is turned off, so anode current is reaches to whenever anode current is reaches to holding current. Okay, so whenever anode current is reaches to holding current, then we can say that SCR is in off state. Okay, so to make the anode current to reduce the holding current, we need this commutation methods. That means, so this commutation which makes the, so commutation is nothing but it can be one external circuit arrangement. By using of the external circuit arrangement, we can apply the reverse voltage to the SCR. This reverse voltage causes the reverse current which is opposite to the main anode current. So this anode current and main anode current and reverse voltage current both are in opposite nature. Then at this moment the resultant current should be decreased to zero or below the holding current. So then only we can we can turn off the SCR. Okay, so that is the process. The process is nothing but we need the commutation circuit. By means of the commutation circuit, we can turn off this SCR. This commutation circuit has the arrangement of one circuit. This circuit causes the reverse voltage. Okay, so to explain this natural commutation, we need the one circuit. That circuit contains the output. The circuit contains the waveforms. Based upon circuit with the help of waveforms, we can explain this natural commutation. Okay, now I'm going to show the one circuit for this natural commutation. And yeah, okay, so this is a natural commutation. So this is, sorry, okay, so this is a natural commutation circuit and where this is waveforms. Okay, so this natural commutation circuit is contains the AC input supply. So natural commutation is which can be applicable for only for AC supply. So that's why I'm taking here AC supply, that is Vs is equal to Vm sin omega t. So this supply is connected to the load through with the help of SCR. Okay, now in case of natural commutation, it can be turned off by the nature of the input supply. That means during the positive off cycle of the input supply, the SCR is in on state. Okay, during the 0 to, now I am considering here 0, this is pi, this is 2 pi, this is 3 pi. From 0 to pi, the input voltage is forward biased. During the forward bias condition, during forward bias applied voltage, this SCR is in forward biased. Whenever it can be forward bias, during forward bias we are applying some gate pulse or firing pulse, then the SCR is in, it becomes a conduction state, that is on state. Okay, after the conduction state, it will flows the anode current to the load, that is the output current will be flowing. Okay, after the pi to 2 pi, what happens? So after the pi to 2 pi, what happens? The reverse voltage is applied to the SCR. This reverse voltage is applied to the SCR. This reverse voltage which causes the reverse current to the reverse current in the SCR. Due to the reverse current, what happens? Previous anode current and reverse voltage current causes the reverse current, and both are in opposite nature, and the net resultant current is becomes 0. So that's why by nature of behavior of the input supply, the output current or SCR current is 0. Whenever the SCR current is 0, what it can shows, the SCR is in turned off. So finally we are concluding the main point is that negative